Welcome back. In the last episode, we explored how high and low pressure systems form, rotate, and affect flying conditions. Now, we're diving deeper into how these systems interact with fronts, weather changes, and the dynamics that shape the skies we fly through every day. Let's start with air masses. An air mass is a large body of air with consistent temperature and humidity. When two different air masses meet, they don't mix easily. The boundary between them is called a front, and that's where the action happens. There are 4 types of fronts: cold, warm, occluded, and stationary. Each one behaves differently and brings its own set of weather characteristics. Understanding these will help you anticipate turbulence, visibility issues, and precipitation along your route. Let's start with cold fronts. These form when a cold air mass pushes under a warm air mass, forcing it upward. Because cold air is denser, it lifts the warm air rapidly, leading to towering cumulus clouds, heavy rain, turbulence, and sometimes thunderstorms. Cold fronts usually move fast, 20 to 30 knots, and are often associated with squall lines and sharp temperature drops. The passage of a cold front brings wind shifts, pressure rises, and clearing skies once it moves through. But the weather leading up to it can be intense. Next up, warm fronts. These occur when warm air slides over a retreating cold air mass. Since the warm air rises gradually, the clouds are layered, first cirrus, then altostratus, and finally nimbostratus, bringing steady rain, drizzle, and lower visibility. Warm fronts move slower, typically 10 to 15 knots, and produce less violent weather than cold fronts. But don't be fooled, low ceilings, fog, and icing can still make flying very challenging, especially during long approaches or descents through thick cloud layers. Now let's talk about occluded fronts. These form when a cold front catches up to a warm front, lifting the warm air off the ground entirely. There are 2 types, cold occlusion and warm occlusion, depending on which air mass is more dominant. Occluded fronts usually bring a mix of weather from both warm and cold fronts, clouds, precipitation, and sometimes embedded thunderstorms. Visibility may drop quickly, and conditions often change rapidly. These fronts are common in mature low-pressure systems. And then we have stationary fronts, where 2 air masses meet but neither one moves significantly. These fronts can sit in place for days, bringing persistent weather, cloud cover, drizzle, or even continuous rainfall. Not dangerous, but definitely annoying. Frontal weather isn't just about rain and clouds, it also affects wind. As a front approaches, expect wind direction and speed to shift. For example, ahead of a cold front, winds often come from the south. Behind it, they swing to the northwest. These wind shifts can cause turbulence, especially at lower altitudes. Be prepared for sudden changes during approach or climb out. And always check NOTAMs or ATIS for expected frontal passages, they can sneak up fast. Another important effect: pressure trends. Before a front arrives, pressure usually falls. After it passes, pressure rises. If your altimeter starts showing a drop while QNH remains constant, a front may be nearby. Cross-check with weather charts and reports. Speaking of charts, let's decode a surface analysis chart. You'll see isobars outlining pressure systems and symbols for fronts, blue triangles for cold, red semicircles for warm, purple for occluded, and alternating red-blue for stationary fronts. By tracking these symbols, you can estimate which areas are getting rain, turbulence, or icing. Combine this with TAFs and SIGMETs, and you get a complete weather picture. Never fly blindly into frontal weather, plan and adapt. Let's talk cloud development. Cold fronts often produce cumulonimbus clouds, with heavy updrafts and embedded thunderstorms. These are dangerous and should be avoided at all costs, especially when flying VFR or near terrain. Warm fronts, on the other hand, tend to form layered clouds like nimbostratus. These produce continuous rain and widespread low ceilings. Icing is a common issue, particularly in the altostratus layer, where supercooled water droplets are abundant. Occluded fronts can do both. They often produce multilayered cloud decks, widespread rain, and turbulent transitions. As a pilot, expect frequent changes in visibility, wind, and altitude performance. It's a challenge for both VFR and IFR. Let's now connect pressure systems and fronts to weather briefings. A typical TAF might read BECMG 26015 KT SCT 020 OVC 040. That tells you, winds from 260 degrees, at 15 knots, with scattered clouds at 2,000 feet and overcast at 4,000. It's likely a warm front's influence. Combine this with METARs and radar imagery, and you can identify which front is moving in. If the ceiling is dropping and pressure is falling, it could be the leading edge of a cold front. If the ceiling is rising and pressure is climbing, the front may have passed. When planning a flight, always check the frontal system's orientation. If your route crosses a cold front, expect more dynamic conditions, potentially storms. If you fly parallel to a warm front, you may deal with widespread cloud and icing but fewer surprises. Altitude matters too. At higher levels, you may be above the frontal clouds, but that doesn't mean you're free of danger. Thunderstorms and clear air turbulence can extend well above the visible cloud tops. Always verify with radar or satellite data. Let's not forget wind shear, especially near frontal boundaries. Rapid changes in wind speed or direction can create dangerous conditions during takeoff or landing. Use caution if flying through a known front, even if the weather looks okay on the surface. Pilots should also know how fronts evolve. A developing front may have weak weather at first, but grow stronger as the pressure contrast increases. Similarly, a dying front might leave behind residual weather like patchy rain, fog, or haze. In flight training and planning, always keep your eye on pressure gradients, temperature shifts, and frontal symbols. These indicators can tell you where trouble is brewing even hours before the worst weather hits your route. Here's a great tip. Use prog charts to forecast where fronts will move over the next 6 to 24 hours. These charts are gold for long flights. They'll show you whether a warm front will block your destination or if a cold front will clear the skies. Understanding frontal behavior helps you build smarter alternatives. If one leg of your flight faces poor frontal weather, reroute or delay. It's not just legal, it's smart airmanship. Remember, flexibility is a pilot's best weather tool. And now for the big picture, pressure systems and fronts don't exist in isolation. They are constantly interacting, forming cyclones, creating storm tracks, and changing upper-level wind patterns. This is the dynamic atmosphere you fly in every day. By learning how fronts behave, how pressure drives wind, and how these elements create real weather, you're no longer flying reactively. You're flying with awareness, and that's the difference between good and great pilots. To recap, fronts form between different air masses. Cold fronts equals rapid lifting, convective weather. Warm fronts equals layered clouds, gradual rain. Occlusions equals complex weather. Stationary fronts equals long-lasting effects. Always check charts and forecast. In our next episode, we'll explore pressure systems, Part 3. We'll focus on advanced scenarios, mountain waves, lee-side lows, cyclogenesis, and how pressure and terrain interact to create local weather threats. It's going to be intense and essential. See you in Meteorology number 07, Pressure Systems, Part 3.